So in this last example, I'm going to use essentially a way of hiding a complete object from people, but also having it automatically instantiated. Now, the limitation of this is that you can only really create like one object in the C file. And there are ways, I guess, you could go about doing and creating multiple objects, but for the simple example of showing how this sort of paradigm works, you can only really create an object. And what I mean by this is that if you create a global variable inside of a C file that is not extern, it's only accessible from inside that C file. And this can be done more explicitly using the word static. Now, static is the same for functions. Static functions are only accessible inside that C file. But what the whole idea is that inside a C file, we create a global variable that is automatically instantiated statically at compile time, which we then use functions, setters and getters to access and to interact with. So the string example, I will keep the same idea going. But what we're going to have to do is that in our source file to, where am I? We'll go into ostring 4. Now in my string, what we're going to do is we'll open up the header file again. So we're going to keep the definition for the string, struct my string in the C file, but we're going to create an object, an instance of it, so in the C file. So the instance will be called, and this is what I mean, like you create an array of objects, you could create 3 or 4 and have different getters and setters where you pass in an index or something, but the basic idea of it is that you create an instance of the object inside your C file so that it's statically allocated at compile time. So struct my string. Now you'll notice this is not a pointer because I'm instantiating the entire string. Now instead, this will be called struct my string, and we'll call this our string as we did before. Now I'm using this reference. This here means that allocate is essentially the same as doing like calloc, where it zeroes out the memory. But this is the way that you write it in syntax for statically allocated variables. Oh, excuse me. Okay. Now we have the problem that what this is going to do is at compile time, that if we compile this, so I'm just going to go ahead and delete this because we won't need this anymore. We'll rewrite it again. So we have this, and then in the header file, we don't need the handles. We're not dealing with any of this again. So we have nothing. Now, in our main, let's open up main, new tab, and go up. Oh, there we are. We'll include my string. We'll keep you because we might use you in a bit. So this is pretty much doing nothing. So our string. So now we'll build this in GDB it, and then I will break at 13. And now I'm pretty sure GDB should be able to tell us our string. Yeah. So GDB is saying, yep, okay, our string has been created, it's inside of this file, it instantiated, but as you can see, we have a null pointer for the string, because we obviously need to allocate the string array. Now, one way you could do this is that to make sure that this is allocated statically, is give it some sort of a length. So we could create like a define, like string buffer length or something, right? And we'll say like, yep, we're going to have 1,000 bytes in our string, and then we can allocate this guy to be string buffer length, right? And if we do this, so we no longer have a pointer, but if we run this, if we make in GDB this again, we can then print our string, and we'll see that we have allocated, but because we use this static zeroing out syntax, we have just got 0, 0, 0, and it repeats an extra 999 times because of the length, right? So this is how it creates an instance of it. Now we can also go and make this static. Hopefully this won't complain to me. And so this is explicitly sort of, oops, it's not doing anything. Explicitly saying that it's only accessible in that one file, but for GDB's purposes, it's still available. Now, to access this object, you can't do it from main. There's no way. Like, because look, our mystring.h here is completely empty, and there's no extern, so the file, this is not possible. So I can't do like our string.string length. This should give me errors. So our string is undeclared. Main doesn't know where it is or what that it exists because there's no extern. Because the extern is what's used to share global variables between C files. But in this case, we're explicitly leaving extern away so that our variable is very much contained to this C file. So then we need to, let's go ahead and create the same API as before to interact with our private string variable. So we're going to create a set and a getter we'll set the string and then we'll get the string and the length. So we'll say we want to get a copy of the string. So we'll return a char pointer to my string get string, and then we'll take in nothing because we're not using a reference or a handle. We're actually going to just return the string from the variable that's been instantiated inside of our C file. Then we're going to return size t, or we'll return we'll firstly write the setter. Probably should write that first. So we'll return an int error code, my string, set string, and then it will take in constant char the string to set, right? And then we need one more getter, which will return size t, my string set get string length. There we go. And we need to include, we'll probably need to include that. I'm an idiot, I was using the wrong quotes. Okay, there we go. So now let's copy across our functions that we want and let's fill out our API. So we got give you, and so nothing goes wrong, we're returning 0 here. Now let's do memory error checking first off. Have they passed us in a null string? If the string to set equals null, return -1, return an error. Now, what next? We want to set the string. Now, we also need to check, hey, we only have 100, we essentially have a maximum length of 1000, but what we can do is we want to then +1 for the null byte, the null terminator. And then we can say, okay, we'll put in what does string length actually return? Returns a size. So we'll go size t string to set length, and we'll say this one's string length, and this is the string. Okay, so now we have we've gotten the length of the string, but now if they're wanting to set a string that's like 2000 bytes in length, we can't copy this in, there's not enough space. And this is a statically allocated buffer, we can't make it larger. This is the disadvantage of having this. If this was a string pointer, like a char pointer, we would then have to just use realloc to make it larger, but we'd also have to initialize this function's array, like this char pointer, by having some sort of a my string init function that's got to be called at the beginning of main. But for now, we'll do some error checking. So if string to set length is greater than string buffer length, we will return -1, another error. We can't do this. So then, assuming that we've gotten this far, that means the string is not null and the string is shorter than our statically allocated buffer. So now we're going to set, we can do two things. We need to set the string length and we need to set the actual string. So we will go and we'll say, okay, our variable's called my string, or our string, sorry. So we'll go our string And this is not a pointer, so I'm just going to use the dot, and we can see string length here equals string to set length that we just found before. And the same thing, we want to string copy. And if we look at the documentation for string copy, it needs a pointer to the destination. Now this guy is a string, a char array, which decays into a string pointer. But to be very, very clear and proper in our coding, we'll put in a typecasted array variable. Never mind, this is going to confuse you. Anyway, we'll just put in char pointer to our string dot string. Whoops, missing a bracket. That's the destination, and we're taking it from the source, which is the string to set. And so that is our set method. Now we want to get the string, and so it's just going to return, same as before, we'll return string dup of, what does string dup take? Takes in a constant char pointer, so we can say, we'll just typecast you to char pointer, better than nothing, our string dot string, done. Return our string, nope, what's going on? Our string dot string length, right? And so now you can see the advantage of this API is that the user can't explicitly set string length. There's no way of them for doing this. The string length is always going to be the length of the string that's stored in it. It's always going to be valid, because the only way to change string length is to load a valid string into the buffer. So this is where you've got this error checking, input checking, whatever. You've added this ability into your API. So now we have our APIs finished here. So what I'm going to do is I'm actually going to open main in the same window, and main is in here. So let's say we want to, let's just print, we'll say char pointer string copy equals my string get string. And it's a void, doesn't take anything as the argument, and then we can print, we'll say we'll also get the size. String size, my string, get string length. So we can print f, we'll say we'll do the same as before, just the decimal and then the, the length and then the string, separated by a colon, print f, oh, missing a quote. First comes string size, string copy. Let's run this, hopefully I'm in the right place. Make. We haven't set anything to it yet, right? That makes a lot of sense. Nothing's been set in it. It's zeroed out. So firstly, let's set something into it. So we have to say, okay, my string set string. And so we're going to say pass in test string. Run this again. And there we go. We've set it in. It's returning the length and returning the string. But there's no way for me to set the length. So this is like one of the good examples of this tight API. We can set the string again to something else. We'll say my string set string to this is a much longer string than the first string. And then we'll do the same thing again, but we'll just do it a bit of a hacky way. Actually, we'll just take him. So this is not very memory safe because this guy here, string copy, is actually just creating a pointer that's not stored anywhere. So this is just a hanging pointer. So this is terrible, but just ignore what I'm doing. Don't do what I'm doing. Do as I say, not as I do. Now what I want the length. So my string get string length, call that, and then here my string get string. Happy, missing a bracket. Why are you green? Something is not happy. Expected. I'm missing a semicolon. This, I'm missing a quote. There we go. There we go. So there's my little API. You keep an instance of the object hidden away in your C file, and you interact with it via the API. So this is the fourth different way of creating an object-oriented object in C. Hopefully this helps. I would recommend all of you, if you've gotten this far watching those videos, well done. But one thing I would really recommend to all of you is to sit down before the project starts on a piece of paper, write out all of the objects you would have, like, you know, what opponents, like if you want to have lots of different opponent spaceships, then you can use something like where you have a handle, or you use the object-oriented style where you return a pointer to the object, like the structure of each individual enemy, which you keep in a list. But for things like the mothership, like the enemy mothership, where there's only ever going to be one of them, you could use an interface similar to this one, where the mothership is always instantiated inside of some C file that you then use an API to interact with. But go down and break up all the blocks that you need, think about which is the best way of sort of structuring the objects, create the API functions. Like, you don't have to write the actual function, but say, hey, I need to be able to set the left position across one block, set the right position across one block. And therefore you can also restrict yourself from, like, you can't ever jump the mothership 10 blocks. You always need to step at one block at a time. So you've restricted the usability of like them, or like how you can interact with the mothership. And so just giving half an hour into writing down on paper and structuring your code project and all of this stuff will mean that the entire thing at the end will be much simpler. So thank you all for watching. If you've gotten this far, you are the top students, and I will maybe see you in another video. I think I'm pretty much done for the semester, so I've had some fun getting this whole thing online. It's been a lot of work, but hopefully my ramblings in front of a laptop camera have taught you a few things. Thank you all. Bye.